Here we look at the physical properties of group 7 elements. Two physical properties we're going to look at is electronegativity and boiling points. So we'll start by looking at electronegativity. And electronegativity is a concept that we introduced in bonding, and we should be able to give us, or you should be able to give a definition for electronegativity. It is the relative ability of an atom to attract a pair of electrons in a covalent bond. And we've got to look at how does electronegativity change as you go down group 7. And the two factors which influence the electronegativity of an atom. First of those is the nuclear charge, and the second is the atomic radius. Nuclear charge, as nuclear charge increases, you'd argue that the electronegativity increases, but also as atomic radius increases, electronegativity will decrease. Now, as you go down group 7, the nuclear charge gets bigger. However, the atomic radius also gets bigger, and that offsets the increase in nuclear charge. So we would state the trend first, and we would say that electronegativity actually decreases down group 7. And then we've got to explain this trend. Why? As you go down group 7, the atomic radius increases, and therefore there is a weaker attraction between the nucleus and the shared pair of electrons, or the bonding pair of electrons. So I've done a few shorthand things there, but obviously you should be writing this out in full. So state the trend. Electronegativity decreases down the group. Why is that? Because as you go down group 7, the atomic radius increases, and therefore there is a weaker attraction between the nucleus and the bonding pair of electrons. Okay, the second physical property we're going to look at is boiling point. Now, first thing we're going to look at is what is it which affects the boiling point, or what is it that influences the boiling point or melting point of a substance. And the first thing that you should be looking at is what type of structure do these group 7 elements have. Well, they all exist as diatomic molecules: fluorine, chlorine, bromine, iodine. We won't be looking at astatine in any of our work in group 7. So all these substances in group 7, fluorine, chlorine, bromine and iodine, they all exist as, and again we need to think about what structure it is, they all exist as simple molecular structures. Again, how can you recognise that? Well, if there are non-metals bonded together and it's not carbon or silicon dioxide, which is sand, then you're going to have a simple molecular structure. With it having a simple molecular structure, then these molecules are going to be held together by intermolecular forces. Now, what we have here, in each case, we've got non-polar molecules, because the two atoms in the molecule have got the same electronegativity. So we've got a non-polar molecule. And as such, the intermolecular forces then will be van der Waals forces. So there'll be van der Waals forces between the molecules. So what is it then which influences the strength of the van der Waals forces? The most important factor is the number of electrons in the molecules. The more electrons the molecule has, the stronger the van der Waals forces between the molecules. So as you go down group 7 here, the number of electrons in the molecules increases, therefore stronger van der Waals forces, and therefore higher boiling points. So you'd say then, state the trend, boiling point increases down group 7. So I've stated the trend there, and then I need to explain the trend. So as you go down group 7, the number of electrons in the molecules, it's important, number of electrons in the molecule increases, therefore stronger van der Waals forces between the molecules. So that there is boiling point. Remember, anytime you're looking at boiling and melting points of substances, you have to look at the type of structure, which we've got here as being simple molecular. If it's a simple molecular structure, then they're going to have intermolecular forces. And then you look at what type of molecule you've got. Is it a polar or non-polar molecule? To determine the type of intermolecular forces. Will all these be non-polar? They'll all have van der Waals forces. And then what affects the strength of van der Waals forces? In this case, as the number of electrons increase, as you go down the group, number of electrons increase in the molecules, therefore stronger van der Waals forces. And that there are the physical properties you need to be aware of group 7 elements.